In the last class, what we have seen what is the need to develop a software which is required to access the database. So what is a database management system? What are the different types of DBMS? So the most popular is RDBMS, which is Relational Database Management System, and how it logically stores the data. So logically it stores the data in form of tables. Tables are nothing but rows and columns, and each row in the table is basically an entity, and the table itself is called the entity set. So all the entities which have the common attributes, they form the entity set. And what are the various popular databases? So Oracle has the maximum market share, followed by IBM DB2 and Microsoft SQL Server. And MySQL is more popular in Bay Area. It's a very lightweight software database, so you can always install it on your machine and work on it. Then nowadays we have object relational database. So because there was need to store complex data, not only simple type of data, so it can store binary data, it can store multimedia files, it can store any kind of documents, and it also supports OOPS concepts like inheritance. So you can actually put some business logic in your database level as well. So earlier the business logic was only in the application layer, but nowadays with these kind of advanced database application, business logic can also be put into the database level, right? So nowadays, since the relational database is heavily dependent on tables, and to extract information from two tables, we need to create joins. Okay, so that makes the query a little slower as compared to if had it been everything information is there into one table. So our databases are generally normalized. So that's the reason there's a different breed of databases which is coming up, which is called no SQL databases. It's an acronym for not only SQL. So what it says that it doesn't use SQL language to access the database, and the data is not stored in the form of table. So it's not a relational database. So definitely the language which is used to access the data would be a different. So here the focus is not on the complexity and the relationship of between the data. The focus is on the simplicity and faster access, reliability and performance of the database. So how fast you can access. So with the advent of lot of data in used by Google, Facebook, Twitter, so they are dealing with the terabytes and petabytes of data. So it was actually getting too difficult to extract fast information from RDBMS. So they came up with these kind of databases, and they are hugely popular, especially in Bay Area. But generally in an application is not dependent on just one type of database. Sometimes it is in combination. So you might have some component which is using NoSQL database, and some part of it, most of the part of it, in object oriented database or object relational database. Okay, and the way the values are stored in NoSQL database is basically key value pairs. So you have key and you have the value. So key is not repeated within a record, and it's actually signifies the column name if you want to correlate it with a table, and this is the actual value. Okay. So we saw that there are 4 types of data relationships between entities, and these relationships are represented in RDBMS in a different way. For example, one-to-one relationship can be represented as a column. Although these are just guidelines, it may differ depending upon how the your DB, a database administrator, perceive that particular application. So this is just a guideline how one-to-one relationship is interpreted in the form of tables. Then 1-to-M generally is interpreted in the form of foreign key relationship, where one table is dependent on the primary key of another table, right? Then we have many to many. Many to many is generally executed with we have to create a third table which represents the relationship between two entity sets, right? So we would be primarily going through a database which comes as a sample database with Oracle, and the name of that database is HR database. So if you start your SQL server, and if you see here, we connected this connection with the HR database, and we'll just walk through what there is. So if you see here, there are countries, departments, employees, job history, jobs, locations, and regions. These are a couple of tables we would be working on. If you expand this, you would see the columns for that particular table. Okay. If you double click on this any table, you will see the table structure. So table structure means what is the column name, what is the data type. Data type means what kind of values this particular column can store. So let us just go brief what are these data types are, and we will be doing these data types in detail uh, in my fourth class. Okay, so employee ID is a type of number. As the name suggests, it can take only numbers or digits. And what is 6 comma 0? 6 is the precision and 0 is the scale. Scale means how many digits are allowed after a decimal point. So it is 0. That means it does not allow any decimal values. It allows only integral values, right? Then first name, and if you see their next column is nullable. Nullable, no means that this value can never be empty. So you need to provide employee ID every time you insert a row, right? Then there are some default values also. So for example, let's say hire date. If I want to just whenever I'm inserting a row, if I give it null, so I want a particular value as a default value. I want to take system data as a default value. So you can always provide some data default value for that particular data. Then we have first name, last name, email. If you see here, these are all varchar2 types. Varchar2 types is a data type which takes all the alphanumeric characters. So we have number. What are the different data types? We have number with precision and scale. So precision means these many digits are allowed. So what is the maximum value of the digit? If let's say if this is an employee ID and it says its number is 6 comma 0. What is the maximum and minimum value which can be stored for this particular employee ID? Just tell me the maximum value. How could it be 6? I say 6 digits are allowed for that particular employee ID. So what is the maximum number with 6 digits? It is 999999, right? And if I say, let's say if I say the precision is 6 comma 2, then what is the maximum value? It says the total number of digits could be 6 and there can be 2 digits after the decimal point. So here the maximum value would be 9999.99. 6 represents the total number of values. It does not represent the integral part of your number. It represents the total number of digits which are allowed in the number, right? And 2 after decimal point. So this we called number data type with precision and scale. Then another data type we saw is varchar2, right? So what is varchar2 means? Varchar2 can take all alphanumeric characters. So if whatever you see on the keyboard, like if it can take A to Z, capital A to Z, or digits and any other special characters, asterisk, some parenthesis, and any other plus, minus. So varchar includes, basically we called in the computer science language, we call it a string which can take any alphanumeric characters allowed. Okay. Then we have date type. So date type, as the name suggests, is can store only dates. So there are different formats in which the date can be stored, and right. So these are the three basic data types. Probably in Oracle there are at least 10 to 15 different types, but these are basic data types. You would be, if you want, you can go ahead and read what are the various data types. Oracle data types. If you see here, there are so many types, and we might be taking couple of them, but the basic one we have already discussed. So clob, nclob, so it can store, since it can store not only simple data, it can store, needs to store some complex data. That means some binary files, some multimedia files, some docs. So that there are different data types to store these kind of data. So we have XML type also. You can actually read about all these things. Okay. Then varchar 2, if you see here, it gives you in a bracket some size, 20 bytes. 20 byte means 20 characters are allowed for this particular value. So first name cannot be more than 20 characters. Last name cannot be more than 25 characters. And nullable, as I've already told you, that first name is nullable. That means, well, while inserting, I can always leave this first name as blank. Blank means blank, it's not spaces, that I can leave it empty. So blank or zero value is not same as null. Null means that particular value is not available at the moment, right? So if you drop down on any of the tables, you can see the various column IDs, and you can see the data types. Okay. You can also, in SQL Developer, you can also see the data. For example, if you click here in this tab, if you see here, this is the data which is there present in this particular table. So we have a couple of rows here. If you scroll down, you will see all the rows. So we have 27 rows here with these values. So every row, as I have mentioned, belongs to an entity set. Entity set is the departments, that is the name of the table, and every row represents in each department. And department ID, if you see here, columns, in the comments it is written primary key of the column, right? So it can never be empty, it has to be some number. And see here, there are some null values. Some null values means for these particular departments, manager ID is not currently available. So we have a question, what is a byte? What is a byte? In computer science, if computer science only understand, or your systems only understands two, I would say, I wouldn't say digits, we call it bits, 0 and 1. Why does it understand this? If you see how the computer is manufactured, all the data is basically stored previously, like when initially computers were manufactured, or the data was stored on punch cards, magnetic tapes. So every data is basically stored in the form of zeros and ones. That means, for example, like if the place is punched, it was considered as 1. If the place is not punched, it was considered as 0. Similarly, on magnetic tape, if a particular you can say cell is magnetized, then it was considered as 1. If it is not magnetized, it is considered as 0. So this collection of cells, you can say, defines a type of data, and your system interprets that you can say strings of these zeros and ones as A, B, C or D, right? So machine language actually consists of only zeros and ones. So we actually in our mathematical system we use digits, right? So digits are from 0 to 9. So digits means D stands for decimal and which stands for 10. So there are 10 characters which are used to define our decimal system, right? This is called decimal system. So in binary system, which is actually used by computers, there are just only two bits. So these are called zeros and ones, right? But we cannot access each and every bit. We access bits in combinations. So the lowest, you can say, the group is called a byte, which is a group of 8 bits. Byte is a group of 8 bits, right? So your program, your computer program can read byte by byte. So for example, when I say yeah, my machine is a 32-bit machine, 32-bit machine or 64-bit machine, what does it mean? It means that your machine is the machine, or the you can say the softwares which are installed, the system programs which are installed on your particular machine is capable of reading 32 bits at a time. So this is called word size, which means the machine is capable of reading 32 bits at a time. So 32 bits means 4 bytes. 4 bytes at a time. Similarly, 64-bit means it can read 8 bytes at a time. So which is going to be faster? A 32-bit machine is going to be faster or a 64-bit machine is going to be faster? So I'm reading some information from the memory. I'm reading some information from the hard disk. So it is for 32-bit it would read 4 bytes and do the processing. For 64-bit it will a 64-bit machine would read 8 bytes from the RAM to do the processing. So which is going to be faster? Definitely it's going to be 64-bit machine. So that's the reason the latest is 64. Nowadays 64 machine are there, and probably 32-bit is also around, and we need to actually write different softwares for reading, because the process in which the way you write a program to process 32-bit would be different from the way you read and write 64-bit, right? So that's the reason sometimes software come in a different executable for 32-bit and 64-bit, right? Okay, so coming back to the SQL developer, if you see here, there are some constraints also. So constraints are nothing, they are the rules that define, the rules are defined on the table. So we have the primary key. Primary key is again is also a rule, right? So what are the rules associated with primary key? So primary key has to be unique. It can never be null, right? So these are the rules. So we have the foreign keys. So if you see here, DEPT LOC FK is a foreign key, and it is actually accessing the table locations. So whatever the primary key of locations is actually used here as the foreign key. Similarly, it has another foreign key which is accessing the table employees. So employee, the name of that constraint is employee ID. So if I show you the data, this manager IDs should be, all these manager IDs are basically some IDs from the employee table, because all managers has to be the employee of the company. So there has to be the associated employee ID in the employees table. That's the reason we define this manager ID as a foreign key. Similarly, location ID, there is a table called locations. If you see here, all these locations, if I define that a department belongs to a particular location, then that location has to be defined somewhere, right? Otherwise, I can say my department is located in XYZ location. So that's the reason this is also defined as the foreign key. So these are the various constraints on a table. So what are constraints? Constraints are the rules defined on a table. Excuse me. Okay. Then we have certain other things also. We have grants, we have statistics, triggers. We will be talking about few of these. So grants means how much privilege do I have? For example, in a company, manager has access to all the tables. So as a tester, probably you might have access to only 2 tables, right? So manager or all the power actually has all the privileges, I would say. The maximum number of privileges are in the hands of DBA, who is also called the super user, and he can grant different privileges, and he can provide different roles. So if there are 5 managers in a company, so they probably would have some role and some level of privileges, and then they might grant some privileges to their team. So if there is a product manager, he might grant some privileges to developers. If it's a QA manager, he might grant some privileges to some QA leads or some testers. So these are the grants. Then we have triggers, dependencies, indexes. We will talk about all these. Triggers are nothing but some kind of procedures or functions used to access the information. So you would be using mostly the column data constraints, and SQL developer gives you a very nice interface to access all these things. But tomorrow in a company, let's say you are working, your database is generally installed on a Linux machine or a Unix machine. A Unix machine does not have a GUI, right? Unix is basically an operating system, just like Windows. Windows, we have, we use mouse. So you click here, and you can drag things. You can do all the mouse activities. On Unix machine, it is basically a command line. So command line operating system means the whole operating system is like this. So you need to write the commands to do certain things. For example, if you want to, here I want to copy paste this. So I would right click and say copy, and I would just paste it somewhere, right? So this is how Windows work. But for Unix, it's basically command line. So you need to type in the commands to perform such tasks. So most of the Unix is a very stable operating system. Most of your real-time databases are installed in Unix. So although we would be teaching, you would be using, you can access your Unix database through SQL Developer. So SQL Developer is basically a client for which the server might be installed somewhere else, right? Right now the server and the client both are installed on my machine. So I am using this Oracle SQL Developer as the client, and my Oracle server, where the actual database is there, that is running, the program that is running actually as a service. So if you see here in your task manager, if you click on services, here you will see the Oracle service. If you see here, there is a listener, and this is the server, Oracle Service XE. And what does listener process do? Listener actually listens to all the client's requests and send it to the server. So SQL developer is sending some kind of requests to the server. So the server might be installed on some other machine. So that other machine in real world is Unix. Most of the time it is Unix. There would be very in real world, um, I don't think anybody would install it on Windows. So Windows is not a very stable operating system because a lot of you can say the processing is of the CPU is used in showing the graphical display. When you don't have the graphical display, there is no that all the processing capabilities and the RAM can be used to make the program faster. So that's the reason Unix is all the command line operating system are much faster and much more stable as compared to Windows based operating system. Okay, so we will be going through some you know initial level of understanding of operating system in our Unix classes. So right now what I mean to say that you need to know, although we would be working extensively on SQL developer, but how to execute that particular command in SQL command line, that also we would be doing. So to execute commands in SQL command line, what you have to do, it is already installed. So if you see here, runs SQL command line. This is the command line interface, and you should be expert in writing commands on the command line. So to connect to the server, so this is again a client, right? We have two clients. One is the GUI based client, which is Oracle SQL Developer, and this is a command line based client. To connect it to the server, I write a command as connect, and I want to connect to HR database. So I say connect HR. Then it asks me for the password. For my machine, password is whitebox QA and it says connected. Now if I get the SQL prompt and it says connected, that means I'm connected to the server and I can write any query here. Let's say I write here select count from employees. Right, so this is a kind of query we would be learning what are the various queries, and mostly as a QA developer or QA analyst, you would be working on select queries. So there are different kinds of queries in SQL, right? So when you type in a query, it gives you some kind of result, right? So this kind of thing we would be doing, and on and off we would be working sometimes on command line or sometimes on this SQL developer, right? So the basic thing which when you are about to start, we have, as I have told you, there is a proper SQL is a structured query language which has in which there are certain commands. So what are these commands and how do we use it? Let's browse it one by one. Okay. So this is an overview of the different types of commands in SQL. So we have first DML commands, which is called data manipulation language. Then we have data definition language, data control language, and transaction control language. So we have DML, DDL, DCL, and TSL, right? So what does data manipulation language means? So there are certain commands in SQL which are used to manipulate the data. So what comes in manipulation? According to the standard SQL, retrieval of data, updations on data, or deletion. All these three operations come in manipulation. And this can be accomplished using DML commands. Right? So what are the basic DML commands? We have select statement, we have insert, and here I forgot. Retrieval, updation, deletion, and insertion. DML retrieval means you are just accessing the data. You're not making any changes. For example, I want to know what is the hire date of a particular employee, right? So I'm just accessing the information. To access the information, we use select command, right? So the first basic command is select command, and it is used to retrieve data, right? Then we have insertion. To insert, for example, I have created a table. Now I want to add a new employee. Now somebody is hired and I need to put that information in the table. So I need to insert a row. So I'm adding an entity in the entity set, right? So which would have certain different values. It would have a different employee ID. It would have a different manager. It would have a different department. It might have the same department, but few other things would be different, right? So we have a different command for insertion. So that command is called insert command. So insert command is used to insert new data, right? Now let's say the employee is transferred from one department to another department. So that particular employee's information is already in the database, but I'm just changing the department ID. So let's say I'm just manipulating uh, just I'm manipulating this data, right? So maybe job ID I'm changing, I'm increasing the salary. So I'm already I'm making changes in the already created data, right? So this is called updation of the data, and the command used for this is update. Make changes in already created data. Okay, then we have delete command. Delete command is used to delete data. To delete data does not mean to delete a particular value, to delete rows, to delete entities, to delete rows, or you can say to delete entities. Right? For example, I want to delete 106 employee information. So I can, this is called deletion of data. If I'm just removing IT prog and making it null, right, then it's not a deletion of data. Probably we are updating this job ID, but we are not deleting the entity, right? So there's a difference between these two. So deletion means deleting the entire row, and updation means even if you are making it null, that means you are removing some information, but you are updating this particular row, right? I hope this is understood. We have this merge command also, which is not generally used very frequently, but merge actually combines insert and update. So if if a particular row, if it exists, then it updates the particular column, otherwise it inserts the new row. So it is just combination, but it is not frequently used. Then we have another set of commands called DDL commands. Now let's say I want to write some information or add some information in a table, but I need to know what the table is, right? I have to first create the empty table. I have to create the structure of the table. Structure of the table means I need to define the table in terms of what are the column names would be there and what are the data types would be there, right? And if there are any foreign keys, if there are any primary key, if there are any default values, so I need to create the table structure, right? So this is the language which is used to manipulate or create the data about data. So this is the data about data. We call this in program database language as metadata. Metadata is data about data, right? And in RDBMS world, the data about data is also stored in form of tables. So there would be some tables which would store the information of how many tables are there in HR, right? So to access these tables and to make changes in these tables, we have different set of commands called DDL commands. Okay, so the basic DDL commands are create table. So when you want to create a table, then you have alter command. Alter command is used to alter the columns. If you want to add a new column, if you want to, you know, update a column with some like with some different data type, you want to change something related to the column. So alter command is used to make changes in the database objects which are already there. And create actually not only creates the table, so we have create table, create index, create procedure. So these are all database objects. So table, index, procedures, triggers, these are all database objects. And create command is used to create those objects. Then we have rename. So rename, as the name suggests, you can rename a table, any database objects you can rename. Okay. Then we have drop. Drop is used to permanently delete the database object. So what is the difference? If somebody asks you, what is the difference between a delete command and a drop command? So drop completely removes the table. Any database objects, whether it's a table, an index, a procedure, a trigger, anything. So it completely removes it with its, along with its contents. Even the structure is removed, right? But in delete, you are not deleting the structure of the table. You are deleting the rows of the table, right? So there's a difference between delete and drop. Delete works on data of the table. Drop works on the database object, right? Then we have truncate. So truncate is basically a very interesting command. Truncate is used to delete all the information from a table. So we have truncate table command only, and it is used to delete all rows from the table in one go, right? So truncate table, what it does, like it is just like delete command, but it is faster. It is faster than delete. So in delete we can have option, right? I can choose what to delete. Truncate doesn't allow me to choose. Truncate is means that you just want to empty that particular table, how many rows there are. So it is faster as compared to delete. So in delete, if I don't put any kind of restrictions, I just say, let's say I say delete from employees. And here I haven't mentioned what employees I want to delete, so that it assumes that it is they are all employees. So it is going to remove all the tables, but it's going to remove rows one by row. It's going to remove rows one by one. Okay, and this in command would be something like truncate table employees. How it executes, it also removes all the rows and the data structures is intact here also. But what it does, it first drops the table, and then it recreates the table using the create table command. Internally, it is a combination of drop and delete. Drop and create. Sorry. So this is the reason why it is faster as compared to delete. So truncate, it's used to delete. It is used to delete all the rows in one go, but it keeps the data structure intact. Okay, so your structure is still there and you can use the table, but the data is all gone. And one more thing. What is the main difference between DML and DDL? Once you make any changes in DML, and if it is not committed, so committed means the changes are permanent. If it is not committed, you can roll back. So you can go back to a previous state. For example, let's say I make some changes in employee's address, right? So for some reason, like I did not commit it, so I did not make changes in the database. So I can actually roll back that particular query. I can roll back that update query. But DDL commands, once they are executed, they can never be rolled back. So they are all permanent. So DML commands can be rolled back. to previous state of data. DDL commands make changes permanent. Whatever the changes is, if it's a create table, if it's rename, if it is anything, makes changes permanent. If it's truncate, once you use truncate, the data is gone forever. You can never retrieve it, right? So it is always committed until the data is committed. Once committed, you cannot make changes here also, but this is always committed. Right? We have there's a question, how do we commit the change? So there are different other kinds of commands also. If you see here, we have transaction control commands. If you see here, this command commit. So commit is going to make your changes permanent. So we'll see what are various transaction control commands also. Then we have, see here, we have create, alter, drop, rename, truncate, comment. You can comment on a particular table also. If you see here, there are comments on every column. So you can put a comment on a table, you can put a comment on a column. These kind of things you can do, right? So it once let's say the DBA might be creating all these designing and all these structures, but apart from DBA, he's not doing it for its own. Probably the table might be used by n other employees of the company, right? How would they know that this particular employee ID actually means the employee ID of the employees table? First thing, they should be, the column names has to be meaningful. Second thing, it's always a good practice to put comments so that the person who is looking at the table, it can relate it to the business logic of the application, right? Is it clear? Then we have different sets of commands called data control language. So what is data control language? As the name suggests, everybody might not have the same kind of privilege depending upon the role and type of access a person has. So various kinds of privileges are allocated to that person. So probably as a tester, I am not allowed to make changes in the database. So I won't be given permission to permission of alter statement or permission of update statements, right? So if you see here, you can always actually change and give permissions. For example, you see here privileges. I can say grant a privilege or revoke a privilege. So I can remove some privileges from a particular user, or I can grant a privilege on a particular user. So in in Oracle, the database name, what is the name of this database which we are working on? The database name is HR. So every user is analogous to the database name. So sometimes is like one user is allocated the one database, and these names are in Oracle specifically only. These terminologies are used interchangeably, user and the database. So HR in this is, so HR is basically the user also, and the name of the database also. Okay. So every user has a different sets of privileges, right? So you can see, I can write here alter so I can write here grant HR select. So HR can do select. So grant HR update. These kind of things I can do. So it's basically select update on grant to HR. So the command is like this. So grant select update to HR. So HR can do select and update on employees. So these kind of privileges I can give to HR. So by default, sys is a user in Oracle. So sys system are the super users which have all the privileges. Have all the privileges. Right? And so generally DBA has access to sys and he can have access to all the tables. So if you see here, I made a connection using sys also, because right now I am the only admin. So there are certain other tables, not only there are some system tables, and if you see here, he can access these are system tables, and if you scroll it down, there are he has access to other users also. So here if you see, we have HR users, so they are anonymous, Apex, so these are some other system related databases. The one which is provided by Oracle as a sample database is HR database. So if you are connected as a system user, you have access to all other users and you have all the privileges on all these databases. So you can allocate the privilege on a whole database, or you can access have privileges on certain database objects as well. Okay. Then we have transaction control language. What is transaction control language? So as we have already mentioned, unless and until you commit the changes are not permanent in the database. So what happens? Let's say I'm typing here something. I'm writing here, let's say select star from employees. It is providing me some query, right? It is giving me some result. So where is that particular data stored, and how is it is displaying it? So my data is actually stored. It's a permanent storage. So what is the permanent storage on your system? So the permanent storage is basically the hard disk. So what does it mean? That once, even if I just switch off the memory, then also the data is stored, whatever there is on the hard disk would be stored. So this is generally called secondary storage devices. Secondary storage devices. So what are the various secondary storage devices? It is your hard disk. It could be your USB drive. It could be a CD, DVD, right? So on and so forth. So they don't need, the changes which are there are permanent. So everything, as we know, is in the form of cells, right? Cells are nothing. They are just magnetized. So electric subs, like in my system, if I have certain cells, so these cells can be there in the memory, or they can be there on the secondary storage device, right? So we have two types of memory. So as we saw, this is the secondary storage device. We have primary memory also. So primary memory actually is refers to RAM, which is random access memory. So if you see my task manager, all the applications, my inbox, Oracle, SQL developer, this is SQL command line, all these are programs. Where are they running? They are running in my memory. They are not running in the hard disks. They need, because my CPU, the brain of that computer, right? It can access data from the memory, but for processing it, It can access data from the hard disk as well as from the memory. But for processing, it needs to put that data into the primary memory. So we have not only RAM, we have other types of memory also. We have registers, we have cache, we have ROM. See, all these are primary memories. So apart from ROM, everything else is volatile. All these memories are volatile. Volatile means once I switch, off the power, everything goes away. And ROM is basically the permanent memory. So when I switch on my system, right, there is something stored. So my OS is basically a software that needs to, again, to work on my machine, that needs to interact with the hardware, right? So my OS is basically a software which needs to be loaded into the memory. So ROM is basically a program which is used to boot the machine. So it's a permanent program, a permanent space where bootable programs are stored. So the programs that loads the operating system into the memory is basically stored in ROM. Okay. So when talking about the databases, so where is database is basically a permanent memory, right? So they are stored in hard disk. But there needs to be, if to view where is, when I say select staff from employees, so it is reading from the hard disk and it is loading that particular data in the memory. So what I'm seeing here, like employee ID, Stephen King, this is basically where this information is coming from. This is coming from the memory. It is loaded from the disk but displayed on the screen by the memory. So what we were talking about transaction control language. So once, if let's say I'm making some changes here, I write an update statement. So to update an employees table, I would be writing some statement like this: update employees, set let's say email is equal to abc@test.com, where employee ID is equal to, let's say, 101, right? And let me just execute this. This is HR.employees. It says one row updated. Now let's see, select star from HR.employees, where employee ID is equal to 101. Okay, now if you see, the email has changed. So where is that change? The change is there in the memory. The change is not committed. If I now, let's say if I close this client, I close this. It asks me, do I need to commit changes, rollback changes? I say rollback changes. No, it closed, right? Now the changes are evaporated because the changes were there in the memory, not on the hard disk. To commit, to make the changes permanent on the hard disk, we need to write the statement commit, right? So that was the difference between DML and DDL. DDL statements are always committed. You don't have to write commit command. But for DML, if you are making any changes, select doesn't make any changes. So select is out of the questions. Insert, update, delete, merge. For all these 4 commands, you need to write commit unless you, until you want to commit, right? Then rollback, if you haven't committed your changes, you can roll back to your previous one. So if had I written rollback, it would have taken me to the previous value. Then save point is like labels. We would be doing save points also. Like it is, if you're writing 5 DMLs and you want to make labels like change mean to roll back to this particular point, then you put a save point. So we will be doing about this. So what does transaction control language means? It allows us to control the statements, the DML statements which we are writing, right? Okay, so let's take rollback. So let's see the I do some delete operation, delete from employees, something like where I'm not writing the entire command. Then I write update employees, and set some values, set email is equal to something something, and then let's say I do another delete from departments, some information. So I have some certain set. I have already done some DML commands and I haven't committed yet. So that means all these changes are there in the memory. Now let's say after doing deletion from this, I want to discard the changes which are done by these two commands. So before writing, actually I would have written here save point, let's say A, and here probably I can write save point B or something like that. So now I can write after this, let's say I want to roll back to save point A. So I would say roll back to save point A. So what it means that all the changes made by these 2 points would be rolled back, right? If I don't write any roll back to save points, all the changes which have been made before the last commit would be rolled back, right? So just to it's kind of a label between the DMLs that I am writing. So these are called save points. We will be doing this in detail, don't worry about it. Okay. Other question was, what is the difference between alter command and update command, right? So as I have shown you, alter is basically a DDL command and update is a DML command. So DML works on data. DDL commands on database objects, not data, right? So update means updating a value of a particular column in a row, right? So what are we updating? We are, let's say I'm updating the email ID, or I'm updating the you can say the name of a person, whatever. So that is I'm updating the data. I would be using update command. Alter command would be used, I would write maybe alter HR add column XYZ. So I am basically altering the structure of the database object, right? So I'm altering the table, right? So I would write alter HR add column, or maybe I would say alter index. So these are database objects. So alter is used to make changes in the database objects, not on the data. So this is the difference between DDL and DML commands. I hope it's clear now. So this was an overview of all the statements that we would be learning in this course. But our main focus would be on select statement. Why select statement? So as a tester, so you would be actually creating your own test data. For example, let's go to some website. Let's say you want to test amazon.com, right? Any web application you want to test. Now let's say one of your test cases is like that. When you mouse hover on shop by department, these kind of categories, these all categories would come over, right? So this is the test data which probably would be coming from some database, right? In the database there would be some table department categories or something, some categories, and these would be categories, and then after in this there would be some subcategories, right? So you need to, there might be two things. You might have to test the queries which are written by the developer. This is the database testing you would be doing, or probably you would be you would be creating your own test data. So you have to probably fetch some data from different tables and create your own test data. So that's the reason you would be extensively working on select. Select means fetching the data according to your requirement. So if you don't want to use department ID or email from a table, from employees table, you just might need the employee name, probably the last name and manager ID. So you can extract that information from the table and use that data into your test programs. So that is the reason you need to know all the variations of select command, and this is probably the most you would be working on, right? So today would be see of how to retrieve data from SQL, data using SQL commands. So the command which was used is called select. Okay, and then we have two types of operations. We have projection and selection. So what does projection means? Projection means selecting the columns which you need. For example, I can always write here select employee ID and last name from employees, right? So what I'm doing, the operation I'm doing projection. Projection means I'm just selecting two columns from the table. So if I run this, I think the name is last name. Last underscore name. Okay, so this is called projection. Projection means you are retrieving data from the selected columns, right? Now let's say from this set of columns I want to retrieve only information of employees whose employee ID is greater than 200. So I would be doing a selection operation. We called it selection operation, where employee ID is let's say greater than 200. So I am actually here. Initially, how many rows were retrieved? All the rows were retrieved, right? So there are around 107 rows. And out of these 107 rows, I want to restrict the data by putting this where clause. So where employee ID is greater than 200, and I'll run this query again. So if you see, only 6 rows are retrieved. So selection operation is basically used to restrict the rows, and projection operation is used to get a particular column. So that's what is displayed here. Then if we have two tables, let's say we have employees and we have department ID. Now I want to let's say I want to, the query is like this: tell me the names of all the employees who work in accounts department. So can I retrieve this information from one table? That I need to have that information because the department name is there in the departments table. So what I'll do, I will first get the department ID of accounts table, and then I'll put a query on this employees table on that particular department ID. So I need the information from both the tables. So to get the information from two or more than two tables, we create a joins. So joins are expensive operation, but they also actually helps in retrieving information from multiple tables, right? So we would be extensively working on select queries and specifically joins and subqueries. And this is the most important topic of this course, because most of the interview questions are based on joins and subqueries only. Okay. So we have seen the basic structure of a select statement. So what this means, select star. Star means I need all the columns. If you don't want all the columns, then you can use give the column names, then from and the table. If you see in a SQL developer, there are certain things which are certain words which are in blue color and the others are in black, right? And some things are in green. So what does it mean? Whatever it is in blue color, there are special words from the SQL language. For every language, whether it's a structured query language or high level language, there are certain keywords that hold special meaning for that language. These keywords cannot be used for any other purpose. For example, I cannot create a table with name select, because select has a different meaning in SQL. Okay, so select, from, where, these are special keywords of the language which holds a special meaning, because select means a statement. Then employee ID, and these everything in black is user created. So I created HR database, I created employees table, last name, and all these things. And in green is basically the values, right? So it becomes really, it is more readable if you do it in SQL Developer. So I as a beginner, I would definitely recommend that you should use SQL Developer, but you should have a good practice of writing the same statements in SQL, command line SQL, and definitely see this is command line SQL provided by Oracle Express. But in general, companies have SQL Plus. SQL Plus is again a command line tool which has the same interface as this command line tool. So that is more popular, right? Okay. So here we are doing projection. So we just want, let's say I just want employee ID and last name. From is followed by the name of the table. Here actually you don't have to prefix it by HR if you are using the HR table only, because mine is basically I am into sys, and sys can access everything. So let me just change my session to HR. So I would say alter session set current schema is equal to HR. Now if I write now I am working as an HR user. So if I write here select star from employees, it's going to give me the result. Okay. So you would be using these kind of queries, right? Select star means select me, give me all the columns from the table employees, right? So let's say if I want to extract manager ID and location ID from departments, what statement would I write? So my question is, display manager ID and department ID from departments where department ID is greater than, let's say 30. So please write me a SQL statement so that this information is displayed. So this would be, so every question we need to break down into few parts. For what I need to display, I need to display the manager ID and department ID. So after select statement, I would be writing the columns. So I would write here manager ID, comma, department ID. Now what table I need to use? So I need to use departments table. So I would be writing from departments, right? And what is the condition? Is there any condition on that? Is there any selection operation? Yes. The condition is department ID has to be greater than 30. So I would be writing here where department ID is greater than 30, right? And I'll execute this statement. So here we have got the manager ID and department ID. If you see here, these are all greater than 30, and this kind of we have retrieved so many rows. So how many rows we have? Number of rows are fetched 24, and it also SQL developer, you also get the time to fetch that data from the server. So it takes 0.042 seconds, right? And if you see here, there is a tab called explain plan. It also tells you how what was the cost. That means what are the complexities of this particular query. So in SQL, the same query might be written in a different way. So you need to do, as a QA, you need to sometimes do query optimization, find the best way to do a query. So that for that actually this really helps. It will tell you like for this particular part, like for department ID greater than 30, it is cost 1, and to access the table by department ID it costs 2. So total cost is basically 2. So to compare two queries, it really helps and takes 0.315 second, right? So this becomes really helpful when you need to compare two queries, right? So we are doing some basic select statement. So if you want to select all the columns, right, select asterisk, or you select the columns which you want to display, followed by from keyword and the table name. So this is a standard syntax of select statement wherein you can fetch data from any of the tables, right? So here it is select star from departments means select all the columns and all the rows. See here we don't have a where clause. So where clause is used to restrict the number of rows. If there is no where clause, that means there are no restrictions. That means all the rows are going to be selected, whatever number of rows are there in that particular table, right? So here we are selecting two columns, department ID and location ID, but all the rows. So there are some you can say some features like SQL statements are not case sensitive, so you can write in uppercase, lowercase. They can be split into more than one line. So as you have seen, I have splitted this one into 3 lines. This is a better way of writing the statements rather than writing the everything in one row. This is more readable. But this kind of thing can be done not only here, you can do this kind of thing in here itself. So unless here you type in semicolon, your statement would not end. For example, if you say select star, so you see automatically it gives the row number, select star from let's say departments. And now if I say semicolon, then it's going to run the query. So you need to put a semicolon at the end of the SQL statement if you are running from command line. In SQL developer, you don't need to. Okay. And keywords cannot be abbreviated or split. Obviously, like from or select, I cannot split. Clauses are usually placed on separate lines. So this is a common syntax. Indents are used to enhance readability. So this is the way how you should write your queries. So in future, your queries will not be as simple as this one. Probably there would be some sub queries, some joins, some statements. So to make it more readable, try to put it into different these keywords in different lines and make it more readable, right? And you can do some kind of indenting also if you want. Then in Oracle 10G, we had iSQL Plus. So I stand for internet. So it was giving you a web interface to interact just like a SQL developer, but 10G is no longer being used. So probably you would say my mostly I use SQL developer, or you can say SQL Plus. So SQL Plus is like this only, and SQL developer is whatever we are using right now. So we won't be doing iSQL Plus. Then what are the various arithmetic operators that can be used? For example, let's say you can actually clear this by clicking this and say here, I want to give, as the owner of the company, I want to give $1,000 bonus to all the employees. So I want not the bonus, maybe probably I would say, let's say I want to increment the salary by 10%, right? So I can do calculations like this. I want to see how what the salary is going to be after 10%. So if you see, I can write this is the way I can put comments in my script. So putting comments in your program is a very good way to make your program more readable. So what I'm trying to do is I'm just typing here um, display salary after 10% increment, right? So if you see here, there is a column called salary. So what I have to display, let's say I want to display the salary. This is the original salary. Now I want to display the salary as 10%. So I can actually create my own column and with the 10% increment. So how can I find the increment? So I would put, it would be salary plus 10% of the salary. So it would be 0.10 multiply by salary, right? So this is my incremented salary, and I from employees, right? I can run this. So if you see here, it gives me the incremented salary. So, but it still doesn't look nice, right? So I want to rename this column as old salary, and this is a new salary. So one way of doing is you put a double quote and write here old salary, and here probably you can say incremented salary. So what I'm doing, I'm renaming the columns, and just remember all these things. If I'm renaming the column, it's just for the display. I'm not renaming the columns on the disk. It is still salary. I'm just using this particular column to display in a more readable way, the way I want, right? So if you run it again, now it really looks nice, old salary and incremented salary. So I can you can see the differences here, right? Another way of giving your own name, customized name, we call that as aliases. So here I can write select same thing. Instead of double quotes, I can write here as old salary, and here I can write as incremented salary. So what I'm doing, I'm giving aliases. Aliases means a different name. So this is again the same thing. Salary as old salary, and here this is the incremented salary. Only one thing you have to keep in mind. Here if you see, there are two words in the alias, right? So I cannot use as there. As expects that there should be only a single word after as. That's the reason I have put a underscore, right? If you want to give a alias with two different words, then you have to put it in double quotes. So now I can run this one, and it's the same thing. If you see here, old salary, incremented salary, right? Okay. Then let's say that you can always do other kind of operations. Here I am doing some mathematical operations. Maybe I want to do some other plus, minus, division. So let's say if I want to find, let's do one exercise. Give me the annual salary of all employees. So please write me a query for this. So this salary column basically gives me the monthly salary. So I want to calculate the annual salary. So what should be my query should look like? So I should have a column like monthly salary with this one, and then I should have a column like annual salary with some values. And please keep in mind, see, I said the annual salary. If there are two words, then you cannot use as. If you're using two words, then you have to use double quotes. Or otherwise, if you just put a underscore or something, right? So your statement would be something like this: select salary, and I can give an alias as monthly salary, comma salary multiply by 12. So this is my annual salary. So I would say annual salary from employees. Right, so it provides me the monthly salary and the annual salary. So if you see here, you can do different kinds of operations. You can do multiplication, division, and in fact you can add and subtract two different columns also. For example, if you see here, there is a commission percent also. So commission percent, let's say the commission percent is on the salary. So I want, this is a percentage, I want the amount. So the next question is find the commission amount for all the employees. For, let's say, for employees working in department 50. How would I do that? So what we are supposed to do here, first we have to write the select statement. So what are we going to display? Commission amount. So commission amount is calculated by percent of the salary, right? So what I can do, I can just say commission percent multiply by salary. So that is, let's say this is the commission amount, and you can give an alias as commission amount, right, for employees working in department 50. So from what table you want to use is employees and working in department 50. That means we are doing the selection operation. So what is the selection operation? Where department ID is equal to 50. So, and you can run this query. So for first few there is null. Actually, for all people in department 50, the commission is actually not provided. If you see here, select star, select commission. So I can write it here also. I'm just adding this so I can tell you what it is, why it is coming null. If you see here, the salary is there, but commission percent is not provided. So if commission percent is not there, how can they calculate commission amount? They cannot calculate commission amount on their own, right? So can I add, subtract anything with a null value? No, I cannot do that. So what is the resultant would always be null. It never assumes that it is zero. To make it zero, we do something else. So that I'm going to tell you. To assume that null is zero, I have to do something I have to write something else. So that we'll see in the next class, what we have to do. But we cannot do any operations with null value. If we do any operation with the null value, then automatically the resultant would be null. That's the reason it is giving me null for all these values, right? So let me just change this to 100, right? If I can get something. No. Again, this is null. I think this is just one department for which values. Okay, so only for department number 80, there is some commission percent given. So then it is telling me the commission amount also. So what I am trying to say is you can do mathematical operations between two columns and you can create your own column also, right? And then you can put some selection operation and just restrict your rows. Okay. So you can do add, subtract, multiply, divide. These kind of operations you can do. So here if you see, we are adding a constant value to salary that we can do, right? I can let's say I want to give $1,000 increment to everybody. So I would say salary plus 1,000 and I can see the incremented value, right? One important thing. So if let's say I write 12 multiplied by salary plus 100. So I want to give 1,000 increment on the annual salary. So let's revamp the question. Find the increment on find the incremented salary if the increment is $1,000 on the annual salary. See, when I write here the increment as 10%, so this 10% was increment on the monthly salary. Salary is monthly salary. See, so I want to see the increment as $1,000 on annual salary. So first I have to find the annual salary like this, right? And then I have to find the increment. So this would be salary multiply by, so let's say I can write here 1,000 plus salary multiply by 12, right? And this I can give a name as increment. Okay, so my question is how this is going to be executed? How this is going to be executed? Whether let's say the salary for an employee is salary is equal to 2,500. Make it simple. Let's make it 2,000. So salary is equal to 2,000. So what would be the value of this? Let's say this is the increment. How it is? What would be the incremented salary? Okay, so I have two answers, three answers in fact. Somebody is writing 2,400, somebody is writing 25,000, and somebody is writing 3,240. This is strange. Anyway, so let's see how it actually calculates. If you remember your maths rules, if I ask you, let's say y is equal to 5 plus x multiplied by 2, where x is equal to 4. What will be the value of y? So most of you know that it is 13. How it is 13? It multiplies the first and then adds. So these are there are certain rules of precedence which are followed. Like it is BOD So B stands for bracket, then off, division, multiplication, addition, and subtraction. So in this order it is executed. Similarly, when I wrote salary multiplied by 1000 plus salary multiplied by 12, so it's going to multiply 12 with 2000. So it's going to be 1000 plus 24,000, and then it's going to add 1 which is equal to 25,000. So 25,000 is the correct answer. Similarly here 4 into 2 8, 8 plus 5 13. So y would be 13, right? So we need to follow certain rules. So that rules are also followed in SQL also. So if you are calculating this thing to make it more clear, although it's going to follow the same rule, but just to make it more readable, you can always put this into a bracket, because bracket is always executed first. So salary multiplied by 12 would be executed first, and then it would be added to 1000, right? Okay, so if I add this, so this would be my annual salary, and 1000 increment on that annual salary will make it 73,000, right? So I'm giving the 1000 increment on the annual salary. So you have to put a parenthesis just to make it more readable. If you don't put a parenthesis, again it would or follow the rules of BOD math, like multiplication and division would be given higher priority precedence as plus. If we have multiplication and division both, or plus and minus both, then it goes from left to right. So it anyway doesn't make any difference, right? So if you do multiplication first or division first, it really doesn't make any difference. Okay. So we have seen a null value is basically a value which is not available, and it's not same as 0 or a blank space. So you cannot do any operations on null value. So if you try to do addition, subtraction, multiplication with any null value, it's always going to be a null value, right? So that's the reason when we multiplied salary with commission person, so all the null values, the resultant was null. For all the non-null values, it calculated, right? Then we have seen the column aliases. Okay, then we can actually do some concatenation also. For example, here we have employees first name and last name, right? So I want to display the full name. So display full name of all employees. So full name is can be done by concatenating, like combining first name and last name. So how I can do, I can write select first name concatenation. So this is basically a pipe, which is, you can be seen this symbol just above your enter key. So this is your vertical bars, 2 vertical bars, and then we have last name from employees, right? So let's run this. If you see here, all these are combined together, right? But it doesn't look nice, right? I need to put a space or something. So I can add a space here. So I'm just adding a space in between these two columns. So this is going to append the space in all the columns. So remember that we are not restricting these rows by putting a where clause. So that means this information is required for all the rows. So I would be writing select first name space last name from employees. And if you run this, the space would be appended between these two, and you can always give an alias as name. Okay, so this is a nice way of displaying it. So for example, like when you are logging into your application, you might see your welcome first name last name, right? Welcome your name. So how this is getting displayed? So for example, let's say I'm here we don't have first name last name. If I'm trying to log in into a certain website, a lot of times your name is displayed. So what happens? The applications queries the database. It tracks it actually fetches your first name and last name, and then it runs a query like this: selects first name, and it concatenates both these things and gets the result, and that result is basically stored in some variable and it is displayed on the screen. So that's how the whole thing works. It might be stored in a different way, but using the select statements we can actually make modification in how we see the results. Okay. So this is called concatenation operator, and you can use this to combine as many as columns you want. So not only the two columns, you can combine three columns, and you can always give your own some keyword or something you want to add. For example, I can ask I can write here, the last name is, so this is a string and I'm concatenating it with the last name, and I can run this query. The last name is Abel. So this particular string is appended to all the last names in the table. So just again, you keep in mind, this is again in the memory. It's not it's like you're displaying the result in this way. You're not changing the name or last name anywhere in the on the table in the disk, right? So you are just making changes in the memory. So there are certain other operators apart from these, and there are certain things. Literal is a character or number or date that is included in the select statement. So what is the literal here? So when I wrote here, the last name is, this is called a literal, right? So when I'm giving the constant values, so this is a string literal, I would say, right? Then this is a varchar literal. When I wrote here 1000, this is a numeric literal. It's a number literal. I'm giving a value, right? So these are literals. Then a date can be a literal too. So we'll see how to use date. Date and character literals value must be enclosed by single quotation marks. So this is character type. So that's the reason I put it into single quotation. I can actually write here 1000 also. So if I put 1000, let's say I'm adding 1000. So this 1000 is basically a literal. It's a character literal. It's not numeric literal, because it is there in the single quotes. Whatever there is a single quotes, it's not considered to be a numeric value. So if you write this, if you run this, it's going to append 1000 at the end of this last name, right? So this is not same as 1000. This is a numeric literal. This is a character literal. You can do, there are some different operations that you can do on numeric literals. So you can plus, minus, add, subtract on numeric. Can you do plus, minus, add on 1000 within quotes? No, you cannot do. You can use concatenation operator on those literals. So the operators which are used with different types of literals vary, right? So in salary, if you see here, salary is basically a number, commission person, manager ID, these are all numbers. So I can do plus, minus, division on these. On varchar 2 I can do only concatenation. There are some other operation also which you can do, but the operator which is used on varchar 2 is concatenation operator. We cannot do plus, minus, division on varchar 2 types. Okay. Each character string is output once for each row returned. So if you see here, this character output is for each row because we are not putting any restrictions. So this is appended for all the rows, right? So we have seen this. You can add your own character strings or character literals. And you can specify your own quotation marks. If, for example, like if you see, if I want to type, let's say, give me something with some literal with quotation marks. Let's say I want to write here, I want to display, it's a nice day today, right? So this is a string literal, but if you see here, from employees, if you see here, it's not showing everything into blue color. Why it is not showing this into blue color? Because it is assuming when it saw the first quotation mark, it thought that the literal is closed here. So it's expecting another quotation mark or something which is not valid. So if I try to run this query, it is going to give me an error. So it gives me some error that from keyword not found where it's expected. So can't I use a literal a single quote within a string which I use? I can do this, but there is a different way of doing this. We have to put Q here and here. So if I put Q outside and just put everything into this square brackets, then it's going to work. Now it's it's a nice day today. So everything is even Q's single quotes can be used as the part of the string. So this is the way you use single quotes as part of the string. Then if you see there, how to just get the eliminate duplicate rows. For example, we have, let's say, I want to find displayed the department IDs from employees table. So I want to display like how many, there might be some departments, right, in which there are no employees. Maybe there's a new department or something. So I would be writing something like this, display department ID from employees, right? So department. So if you see here, there are might be 3 employees in 90 and 5 in 60, and so these rows are kind of repeated, right? So these values are repeated. I don't want repeated values. I just want maybe I want to display the distinct department IDs. I just want to know what are the distinct values of these department IDs. So I have to just append this distinct keyword in front of this and run this again. So if you see here, now it gives me distinct values. Even null is a distinct value because it is different from others. So it gives me all the distinct values for that particular column. So distinct keyword is on a particular column to display the distinct values of all for that column, right? So my question is, if I write here select, let's say the table has 107 rows. Let me write this query here. Let's say the table has 100 rows with primary key employee ID, and I write a query like select distinct employee ID from employees. So how many rows would be fetched? What would be the distinct values for this? How many rows would be fetched for this particular query? So they would be 100 because employee ID are all unique, right? There are no duplicates. So that means 100 rows would be fetched. So to fetch unique rows, we use the keyword distinct. Okay. One more interesting thing, you might be using this. See, I have written so many queries in this particular script. So I can always save this script as a .sql file. So here I have already created, let's see, maybe I can save it as s1.sql. And if I close it, and I can actually open it again and then run the query. So I can say open s1.sql. So you can save your scripts in .sql file, and you can create your .sql files right in here in the SQL developer, or simply you can create your .sql file in Notepad. So I can write here select star from employees, and you can say maybe I can write some more queries here like select employee ID from departments, whatever, like, and you can save it as ABC and click on all files .sql. So the extension would be .sql, and you can just save it anywhere you feel like. Okay, and you can open it from your SQL developer, and you can run it from command prompt. So to run a .sql query, you would be writing something, right? @ and you have to give the path. So let's say the path is it is saved at training abc.sql. So whatever the commands are there in this particular abc.sql, all would be executed in one go, right? This is how you can actually execute your .sql from command prompt, and here you can execute .sql by clicking on this particular run script. So this is going to run all the commands that are present here. You run this script. See here all the scripts, whatever it is running there, everything is running. And you can scroll up and see the result. So all the scripts are running in one go. So this is a nice way to run multiple SQL statements. So iSQL Plus was there in its web interface in Oracle 10. So we don't have iSQL interface in 11. Express Edition doesn't give you enterprise managed application, but it still gives you a web client. So if you click here and say get started, it actually opens an interface in your default browser, and this is basically an Oracle web client, and you can access your database through browser also. So you don't need SQL command line or SQL developer. But this is definitely a little bit slower, so generally people don't prefer using it, but this is also allowed. So because the SQL server is running as a service at this particular port. See here, this is your web client, and you can log into your database. And you can see the sessions. You need to enter through sys or you can enter through HR. Sometimes it does not allow, so if it doesn't work, don't worry about that. So I'm just trying if it works. Let me log in as sys. It might allow me to work as sys because HR doesn't have all the privileges. It's not allowing me to connect to sys. So anyway, I'll look into this. Probably I have to connect through HR only. It's locked. What the Oracle does, it does locking, and it does not allow you to enter. So I'm just connecting through HR, and maybe through SQL Developer if I'm connected, I might be able to change. So every if I'm trying to make modifications from different clients, so there is a lock which is obtained by the database, and it doesn't allow the other client to modify it. So that's the reason. So here I have three clients. I have a SQL developer, I have SQL command line, and I do have a web client. So that's the reason it's not allowing me to enter. So probably I have to log out from one of these and then log in again. So I'll do it that later. So you can try doing that. You have to log out everything, connect using sys, then it will allow you to log in. Then how to find, so we have seen through SQL developer, definitely we can see what is the table structure. But let's say if you want to see the table structure through command line. So there is a command called describe. So if I say describe and write the table name, it will tell me what are the various column names and whether they are nullable, not nullable, and the type. So everything I can write, see there in the here my describe describe commands. Describe followed by the table name gives you the information of the column. So whatever we are doing, please try to practice that in your command line as well, right? So we know how to start my script files, save my script files. Okay. Now to restrict the number of rows, we know that we have to use where clause. So how to use where clause? And we have seen there are certain operators that we can use. So if the column name on which restriction is to be put is a numeric column, then I can use equal to, greater than, less than, right? So I can we have already seen this. If I want to display the employees which belong to department ID 50, say. So what I will do, I would say select star from employees where department ID is equal to 50, right? So equal to here I can use only if department ID is numeric. In fact, for equal to can be used for string literals also. So if I, let's say I want to find all information of the employees where last name is equal to King. So when I'm comparing the string literals, I have to put a string literal here, right? So this is basically a varchar, so I need to compare it with a string literal, and single quotes needs to be provided. So it is going to give me information of so what is wrong? So it gives me information of the employees where last name is equal to King. No, now for by mistake I've put G as the capital. Now small g and capital G have are different characters. So now if I try to run this query, it won't fetch me any results. There are no results because it cannot find this. So you have to be very careful when you are doing comparisons by equal to, right? So equal to works both for string literals and numeric. But there are other operators. For example, let's say I want information. So I want display employees whose salary is greater than 4,000, right? So how would I write? Select, let's say I just want to know the employee ID and salary. Salary from employees where salary is greater than 4,000. Right? So if you see here, it is producing the result, and all these employees have salary greater than 4,000, right? So greater than, less than, greater than, equal to. So we have certain operators like this. So what are the various mathematical operators? So there are plus, minus, division and multiplication. Then we have relational operators. which is greater than, less than, greater than, equal to, less than, equal to, and then we have not equal to. So we have not equal to like this. So I want to, let's say I want to display employees who do not belong to department ID 50, right? So how would I write here? Select, let's say star from employees where department ID not equal to 50. So you can write it like this. And if you see here, these are all the employees. If you see here, they do not belong to department number 50, right? So these are the these are relational operators, less than, greater than, equal to, right? Then we have another category of operators which are called logical operators. These are not, and or. So what does not means? Not means opposite. So not is basically a unary operator. So we have unary operators and binary operators. So what is the difference between a unary operator and binary operator? Unary operators, takes one operand and binary operator takes two operand. For example, plus is a binary operator. So we write 2 plus 3, right? So we need two operands. 2 and 3 are two operands, then only it's give me result 5, right? So binary operators are basically operators which need two operands. So these are all binary operators, greater than, less than, these are whatever we have seen here, these are binary operators. Not is basically a unary operator. So I can write here not of, let's say I not of true. So not of true would be false. So logical operators, you can say the operands here are basically true and false. What does it mean? Let's demonstrate it by giving an example. Let's say I want to display employees who are working in department 50 and their salary is greater than, let's say 5,000, right? So how would I write here? Select, let's say I want to display employee ID, comma, department ID, comma, salary from employees where, so there here we don't have one condition, we have two conditions. And these, both the two conditions needs to be true, right? We need that the workers should be working in department 50 and their salary should be greater than 0. So this is true and true. Then only I want the result. Otherwise I don't want, because there might be some people in department 50 whose salary is less than 5,000, right? I don't want them. So I want both of these conditions to be true. So for this purpose, I would be writing a statement like this, where where department ID is equal to 50 and salary is greater than 5,000. So let us run this query. Yeah. Here if you see, here the department ID is 50, right? And the salary is greater than 5,000. So both these, if these two conditions are satisfied, then only I would be getting the result. So this result is obtained with both of these conditions. Now let's say I want to display, let's say I want to see the increase the increment of only those employees who are in 50 or and 90. So maybe I want to display all employees info who are in department 50 or in department 90. Okay, so either this kind of condition is there, either this or this, right? Then you put, how do you write this? So you say select employee ID comma department ID from employees where department ID is equal to 50 or department ID is equal to 90. And you can run this query. See here, these are all the employees which are in department 90 or in 50, right? So it's not necessary that you have to put condition on the same column ID. So I can have I can use different column IDs for both the conditions. Like here, see, we have department ID and salary as the condition. Here we have the same column as the condition. I can have for all also, like let's do the same thing. So who are working in department 50 or their salary is greater than 50,000. So here instead of and, I would be writing or. See here, although this department is 90, but the salary is 34560. So this condition is satisfied. For others, let's say for this one, this department is 50, but the salary is less. So one condition is satisfied. Or means at least one of the conditions is satisfied. That is meant by or. At least one. It can be both also, but at least one is there. Okay. Then we have not operation. Not means opposite of this. For example, I want to display the employees info who are not present in department 50. So how can I write this? Select employee ID comma department ID from employees where not of some condition, right? So department ID is equal to 50. So I'm just making sure that whatever the result of this is there, it is not of this. So wherever the column value is not 50, it's going to fetch me the result. So you see here, so not means opposite of this. So it's going to evaluate this one and just tell me whether it is true or false. and then it's going to fetch the result opposite of this. If this is right, whatever is there, if let's say if I write here salary greater than 5,000, so just the opposite of that it's going to be fetched. Not means whatever is there, just the opposite. So here that's the opposite. So we don't have any employee with department number 50 here. So we have seen three types of operators: mathematical, relational, and logical operators. So in SQL, there are a couple of more. So we'll see. So we have seen last name is equal to like this, and these are comparison operators. And these are also called relational operators, as we have seen. In SQL, there are few more: between, and, in, like, and is null. So let's see what does this mean. For example, I want to display all employees whose salary lies between 5,000 and let's say 7,000. So here I would write, so there are two ways of doing this. Select employee ID, comma, salary from employees where salary is greater than equal to 5,000 and salary less than equal to 7,000. This is one way of doing this, and I can do the same query in other way. Where salary between 5,000 and 7,000. So it's going to fetch me the same result. So we have 15 rows selected, right? And for this, again, there are 15 rows selected, right? So between again is basically meant for only numeric data types, and it's going to fetch me between two values inclusive of these two values. So 5,000 and 7,000 is also included. So this is the equivalent of this between, right? Then we have in, like, and is null. What does in means? For example, here I want to display employees whose manager ID is let's say 100 or 101 or 102, right? So what are the two ways of writing this kind of query? So what I'll do, so we can write instead of salary, let's say manager ID. I can write manager ID is equal to 100 or manager ID is equal to 101 or manager ID is equal to 102. And what is the other way of writing this? We can use in statement, in clause. Where manager ID in bracket, and I'm going to write here values 100, 101, 102. So let's see how many rows this fetch. Okay, so we have 20 rows. We have couple of them in 100 and in 102 and 101, and this is also going to fetch me the same result. 20 rows, right? So this is actually a compact way of writing multiple or statements. So this means manager ID is equal to 100 or manager ID equal to 101 or manager ID equal to 102, right? Then we have like operator. So this was all the matching or the operators, and in can also be used for what you call string literals also, or like means varchar types also. So if your question is like this, display the employees whose last name is King or I need to know some last names. Last name is King or let's say Chen and Ku. King or Chen or Ku. So how would I write here? Again I would write where last name in, and since it is a string literal I would be writing here in quotes King comma Chen comma Ku. So if you see here, there are two with King and one with Chen and Ku. So in can be used for both numeric as well as non-numeric, right? Then let's say I want to display the employee whose last name starts with K, right? So how can I do that? So for this kind of question, you need to use like operator. So how would you do that? Where last name like K followed by percent. So I just want it to be starting with K followed by any number of characters, right? So for any number of characters, I can simply write K percent. So percent can be replaced by any number of characters. So if I run this query, so these are all the last names that starts with K. So similarly, if I want all the last names that ends with G, so how would I write that query? Display employees whose last name ends with, let's say, small g. So how can I write the query for this? So how would I write this? The same query I would write percent %g, and I'll run this. So all these last names ends with K. Now let's say the query is like this. I want to display the names, display employees whose last name contains A, right? Then how can do that? So the left can be anything, the right can be anything. So I can write here percent A percent, right? So left can be anything. So this is by contains A. So it can be anywhere. It can be at first position, second position, third, last, anywhere. So this is the way you would be writing the query. So here you will find A at any of the positions, right? Now assume that I want to display the employees whose last name, the second alphabet is A. So how what I want is display employees whose last name second character is A, right? So how would you write this statement? So now this is specific, right? So exactly there should be the only one character before A, right? So how would I write here? Again, I write here, copy this. So I would write here last name. Instead of percent, I would be writing underscore. So underscore basically replaces just one character. Percent replaces as many characters, but underscore first character. So it says first character can be anything, but second character has to be A followed by any number of characters. So let's see if we have any last names like this. So in all these last names, if you see this first name, first letter could be anything, but the second letter in all these are A, right? So we have seen so it matches a character pattern. Underscore replaces one character, percent replaces multiple, zero or multiple characters, right? Then let's say I want to find the null values, right? So in this table, only commission percent has null value. So I want to display employees whose commission percent is not available, right? So how would I write? Select employee ID, comma, commission percent from employees where commission percent is null. Here, please note down this thing. Equal to will not work. Equal to means equality. If something is not available, how can we equate? We cannot equate. We can only equate if some value is given. So SQL provides is clause to find out null values, and here this is the way you can find null values, right? So if you run this, you will get all the employees whose commission percent is null. Is null is the key, right? Not equal to null. So this is one of the very common mistake everybody does. They equate, write it is equal to null, which is not the correct syntax of finding null values. Okay, so these are the various comparison conditions or comparison operators. So we have seen salary, like these are numeric ones. We have seen between, in condition, like condition. Like is used for pattern matching, pattern matching, and always remember that lowercase and uppercase are different characters using the null conditions. Logical operators we have seen and or not. So and returns true if both the component conditions are true, or either or not just give you the opposite of whatever the condition is there. Okay, and you can see here you can combine salary greater than 1,000 and this. So always logical operators have lower precedence than comparison on mathematical. So these are evaluated first. Now this is as first order of preference, then relational operators are evaluated, and then logical operators. So if your statement has all these three operators like this, it has greater. So let me just give you an example. Okay. So select employees Select employee ID comma salary from employees where, let's say, salary is greater than 1000 plus 200 and department is equal to 50. So this condition, how is this going to be, this expression, how is this going to be evaluated? First, 1000 plus 200 would be evaluated first. So it would be like salary greater than 1200. Then comparison operators will be evaluated. So how this will be evaluated? Salary greater than 1200 and department equal to 50. So first this would be evaluated, then this would be evaluated. Let's say for both, if they're true and true, then and would be evaluated. This is the order of precedence in which and expression is being evaluated. So I hope logical operators are clear and how these operators are evaluated. So we have seen the example for not. Similarly, we can do not in also. So here it is going to fetch me all the employees where job IDs are not any of these. If you see here the result, these job IDs are not IT procs, ST clerk or SA rep. So these are not any of these. Okay. So this is evaluated like this, job ID not equal to IT proc and job ID not equal to ST clerk and job ID not equal to SA rep. So if these are not out of this subset, then it's going to be fetched. Okay. So rules of precedence we have seen, arithmetic, then concatenation operator if it's then we have comparison, then is null like, between, not equal to, not logical, or and this. So you can remember arithmetic, then comparison, and then logical. So this is just an example of how it would be evaluated. And if there are or and, right? So and is has a higher precedence over or. So if both are there, then it would be evaluated like this, right? So this would be evaluated first, and whatever the result of this, then it would be evaluated. So if you want this first expression to be evaluated, you need to put that into parentheses because that then it holds the higher precedence. Okay. Now let's say that you want to sort the result. For example, you want to display the salaries in ascending order. So for this we have a clause called order by. So we say select employee ID comma salary from employees order by salary. By default, if I don't mention ascending, it automatically by default it so gives me the result in ascending order. So if you run this, if you see here, the salaries have been, the rows have been ordered by or sorted by the salary, right? So these two have the same salaries. These three have the same salaries. Okay. Then now let's say I want to display the department ID also. Okay, so these two people have these three people belong to different departments. These two people are in different departments. Still displaying. Okay, so let's say if two people have the same salary, then I want to sort by department. So here if you see in this example, 50 and 51st row, here these two people have the same salary, right? Now if on the same salary, I want to sort by department. Now it is not sorted, right? It is displaying 60 and 20. So second level of ordering, I would say department ID. So remember these two with 6,000. So now if I run this query, and see 6,000 now. Here if you see now, if they have the same salary, now it is sorted by department ID, right? So you got my point. So we can do nested sorting. We call this nested sorting. So on the high level sorting would be on salary. If the salary is same, then it would be sorted by department ID. Similarly, we can do sub sorting also. Even if the department ID is also same, then let's say here if you see this example, salary is same, department ID is also same. Now for this kind of case, I want to sort on employee ID. So I can write a third level of sorting, ordering also. So I can write here employee ID. Now let us run this again. So if you see here, salary and department are same, but they are ordered now by employee ID. So you can go to any level of sub ordering. This is called nested ordering, and we can go and definitely we can change the order. For example, here if the salary is same, I want department of ID to be in descending order. So how can I do that? I can simply write descending, right? So if I don't mention anything, it is ascending or ASC. You don't have to write it. You can omit this, or if it you can actually change. So if you run this, the salary is same, it would be ordered on descending by department, and if department is also same, then it would be ordered in the form of employee ID. So let us try to run this again. So here if you see if the salary is same, yeah, so if you see here 2,500 salary is same, but for the department it is sorting in descending order, right? And if the department ID is also same, then employee ID is sorted by ascending order. So you can always give what kind of sorting you want to do on a particular column. So this is the highest level, this is the sub level, and this is the sub level. So you can go on anywhere like this. So you can order by any column name. So you can order by hire date, job ID. So hire date means ascending order means the last date. So the oldest one would come first. So here if you see 17 June 87 is coming first, and 21st May 91 is the last. So ascending means the oldest first, and you can order by characters also, not in necessarily you can order by numeric. So character means it will A would have A would come first and Z would come late, right? So it is just like that. And capital and lower letter also, small letters and capital letters, you can find out which has the lowest precedence and which takes the higher one. So you can order by any of any data type. You can order by date, you can order by number, or you can order by any varchar type. Okay. and you can give the order name also. You can give by this. One more interesting thing, you can order by the column name also which you have given. For example, we had already mentioned calculated the salary, right? So where did we calculated the salary? Here we page. We calculated annual salary somewhere, right? Okay. So here if you see, I have given this alias as annual salary. So here also I can say order by annual salary. So you can give any column name in this order by clause. So whether it is your customized or alias which you have created, or it is the column name defined by the tables, you can give anything. So you can run this query like this. If you see here, it is being ordered by the in ascending order by the annual salary. Okay, so you can use aliases also. Right? You can sort by multiple columns. As we have seen, this would be your higher level sorting. So if the value for two columns is same, then it would be sorted by salary in descending order. Okay. Yes, the ordering is done on the first column, and if the column has the same value, then the ordering would be done on the basis of the second column. Okay. Okay. So then we have substitution variables. What does substitution variables means? For example, let's say I want to run a query like this. I want to get employees info for department ID 50, right? So how would I write query? Select star from employees where department ID is equal to 50, right? Simple. Now let's say I want to run this query 10 times a day, or maybe 50 times a day, right? So I would be writing maybe for different department IDs. First I want to run it for 50, maybe for 100. So what I can do, instead of 50, I can write ampersand, and I can say give some name to this department ID, any name you like, and then run this query. See what happens. So it asks me what department ID you want. So for what it is going to replace this particular variable with this value. So it is going to run it by select star from employees where department ID is equal to 50. So this is the query wherein the department ID is 50. So now let me run this query again. Now I want to fetch it for 100. Is equal to 100. So this is, so I am not rewriting the query. I have written the query just once. So it actually helps sometimes, like if you want to run the query with different values, set of values, then you might use substitution variable. So when you write ampersand in front of any variable, so it becomes a substitution variable and it asks that value at the runtime. So in fact, I can use table name also as a substitution. So I can write here ampersand table. So I can table name. So if I run this query, it's going to ask me for two. So table name is employees. Then it is going to ask me department, and let's say department is 30. So it is fetching me the data for select star from employees where department ID is equal to 30. So that's the advantage of using substitution variables, right? And you can write your scripts and save it with substitution variables, and then you can run that scripts n number of times. Okay, so you can use substitution variable in where clause, from clause, select clause, anywhere you feel like. So you can replace column names, table names, values, everything from substitution variables. Okay. Okay. So